This is section 9.3 of Honors Algebra 2, Parabolas. We've encountered parabolas before because we've seen that they are the graphs of quadratic equations. But we haven't really said anything about the specific shape of a parabola other than we know there's a vertex and we know there's some symmetry going on. So in this section we're going to explore that shape in a mathematical way and try to come up with an equation if we know the parabola. So we're going to work backwards. We know how to graph a quadratic equation as a parabola, but now we're going to take the parabola and write an equation. So let's consider a point that we will call the focus. My focus here is going to be 3, 0. So I'll graph that. And a line that we'll call the directrix. My line is going to be y equals 4. What kind of a line is that? That's a horizontal line at 4. Okay, so that point is 0, 4. So my horizontal line goes through that point. That's the line y equals 4. Okay, that's my directrix. So I've got a point and I've got a line. Now I want to graph all of the points that are the same distance away from the focus as they are from the line. All of the points whose distance to the focus, to that point, is the same as its distance to the line. Well, one of those points is really easy to find. It's the one that's exactly halfway between the point and the line. So that's this point right here. That's the point 3, 2, because it's a distance of 2 away from the focus and a distance of 2 away from the line. What other points are the same distance away from the focus as they are from the line? Let me show you an animation. So I've got the focus and I've got the directrix. And point A is the point that's halfway between them. Point that's equidistant between the focus and the directrix. So watch what happens as I drag B along here. Anywhere I stop, the distance from A to B is the same as the distance from A to the focus. And I can keep going. Any point that's on here, the distance from A to B is the same as the distance from A to the focus. You can go up here. The distance from A to B is the same as the distance from A to the focus. I can go over here. The distance from A to B is the same as the distance from A to the focus. Okay? All of these places, the distance from A to B is the same as the distance from A to the focus. So watch what happens if I click Animate. It traces all along there. And what shape forms? Well, it's exactly a parabolic curve, where every point on that graph is the same distance to the focus as it is to that line. Pretty cool. So that's the way we're going to define a parabola. It's a set of all the points that are the same distance away from a focus as they are from a line. So my parabola here is going to look something like this. Or if I pick a point on here, let's say this point here, we'll call it P, which has some x-coordinate, some y-coordinate. Distance from P to the focus is the same as the distance from P to the line. Those are equal. Okay? Let's try to come up with an equation for this parabola then. Well, we'll apply the distance formula. P, x comma y, is a point on the graph. Then PD is the distance from P to the directrix line. So that's right here. That's our PD. And PF is the distance from P to the focus of 3, 0. I know that those distances are the same. PD equals PF. Let's use the distance formula on both sides of this. So what's the distance from P to the directrix line y equals 4? Well, if this is the point x, y, it must have the same, or the point up here on the directrix line must have the same x-coordinate as my point does. So that point right here must be the point x, 4. It has the same x-coordinate as the point on the parabola, and its y-coordinate is 4 because it's on the line. So PD is the distance from x comma 4 to x comma y. Alright? So that means I will have x minus x, quantity squared, plus y minus 4, quantity squared. distance from xy to x comma 4. That's going to equal PF. PF is going to be the square root. Now, F is 3, 0, and my point is xy. So I'm going to have the distance from xy to 3, 0. So I'll have x minus 3 quantity squared plus y minus 0 quantity squared. I just applied the distance formula to find PD and PF. So now I've got a square root over everything, so let's square both sides and get rid of both of those. We'll have x minus x squared plus y minus 4 squared equals x minus 3 squared plus y minus 0 squared. Now let's simplify. X minus x is 0. So that whole term goes out. We've got y minus 4 quantity squared equals x minus 3 quantity squared plus y minus 0 is just y, so we'll have y squared. Okay, I'm going to FOIL out the y minus 4 squared, but I'm not going to FOIL out the x minus 3 squared. So FOILing out y minus 4 squared gives me y squared minus 8y plus 16. That equals x minus 3 quantity squared plus y squared. And the reason I did that is because now I can cancel the y squared on both sides. I can subtract that off from both sides. So I've got negative 8y plus 16 equals x minus 3 quantity squared. Okay. I'm going to take the left side and I'm going to factor out a negative 8. Notice that I can do that. And I'll have y minus 2. If I take 16 divided by negative 8, I get negative 2. That equals x minus 3 quantity squared. Okay? I'm going to divide both sides by negative 8. That'll give me y minus 2 on the left. And on the right, dividing by negative 8 is really the same as multiplying by negative 1/8. So that's the way I'm going to write it. I'm going to write it as negative 1/8 times x minus 3 squared. And that's my equation. You'll notice we've seen equations in that form before. That is the vertex form of a quadratic equation, where the vertex is 3, 2. That was my vertex up here. The vertex is exactly the point halfway between the focus and the directrix. Notice my parabola opened down. Well, how do I know that in my equation? There's a negative in front of the 1/8. Okay? Cool. So we've just confirmed that the graph of any parabola is a quadratic equation. So a parabola, then, by definition, is the set of all points equidistant from a fixed line, called the directrix, and a fixed point not on the line, called the focus. Notice the focus is always inside the parabola. Before my parabola opened down, the directrix line was above it, and the focus was on the inside. Okay? Focus will always be on the inside, the directrix on the outside. For example, the vertex of a parabola is negative 5, 1, and the directrix is the line y equals negative 2. Let's find the focus. So it's going to help if we draw a graph. The vertex is at negative 5, 1, and the directrix is the line y equals negative 2. So that's this horizontal line down here. I've got negative 5, 1, my vertex, and the directrix is the line y equals negative 2. So I know this point right here, directly below the vertex, must be the point negative 5, negative 2. So the vertex is exactly halfway between the directrix and the focus. That means the focus must be above the vertex here. So what's the distance from the vertex to the directrix? Well, that looks like 3. So if I go up 3 from the vertex, I should land at the focus. And that will be the point negative 5, 4. So just to give you a sense of how this works, the parabola must look like this then, where the focus is on the inside. Okay? So I've found the distance from the vertex to the directrix. That was 3. I then go 3 in the other direction of the vertex, so in this case up, to find the focus. The focus must be the point negative 5, 4. Cool. Number 2, find an equation of the parabola having the point f, which would be 0, negative 2 as the focus, and the line x equals 3 as the directrix, and graph it. We're going to find an equation where the focus is at 0, negative 2, right there. The directrix is the line x equals 3. Okay. So there's a point 3, 0. So if the vertex is exactly halfway between the focus and the directrix, the vertex must be here at 1.5, negative 2, or 3/2, negative 2. Now, let's find the equation the same way we found it before, using the distance formula. So I know PD equals PF, where P is a point x, y on my parabola. Right? So just like before, I'll have square roots on both sides using the distance formula. PD is the distance from P to D, where P is the points x, y. So it's going to be somewhere, let's say it's here, just to give us a sense of where it is. That means that's x, y, and this point right here is at 3, y. We'll have the same y coordinate, but the x coordinate must be 3 because it's on the line. And then that's my PF. Here's my PD. Okay, so PD is going to be the distance from xy to 3y. So x minus 3 plus y minus y, and squaring both of those things and adding them up and taking the square root. PF is the distance from x, y to the focus of 0, negative 2. So x minus 0 squared plus y minus negative 2, which is plus 2 squared. Okay? Square both sides. X minus 3 squared plus y minus y squared equals x minus 0 squared plus y plus 2 squared. Simplify, x minus 3 squared plus 0, so nothing there, equals x squared plus y plus 2 squared. Alright, since I've got an x squared on the right hand side that I like to cancel out, I'm going to FOIL out the left hand side so that I can cancel an x squared. So I'll have x squared minus 6x plus 9 equals x squared plus y plus 2 squared. Now I can cancel that x squared with that one. Factor out a negative 6 over here because that's what's in front of x. That'll leave me with x minus 9 divided by 6, which is 3 divided by 2, 3 over 2. And that equals y plus 2 squared. Divide both sides by negative 6, and I get x minus 3/2 equals 1 over negative 6 times y plus 2 squared, because dividing by negative 6 is the same as multiplying by 1 over negative 6. So that's my equation. It looks like the equation we had before, but the x and the y have changed places. And that's because my parabola this time opens horizontally. In this case, it opens to the left. If it opens vertically, up or down, then the x term is squared, and the y is on the left side. If it opens horizontally, left or right, then the y term is squared like it is here, and the x term is on the left-hand side. Okay? So let's generalize that. Let the absolute value of c be the distance between the focus and the vertex. If the focus is above the vertex, or to the right of the vertex, then c is positive, and the parabola opens up or to the right. If the focus is below the vertex, or to the left of the vertex, then c is negative, and the parabola opens down or to the left. Let a then be 1 over 4c, and let the vertex be h, k. Then the parabola whose equation is y minus k equals a times x minus h squared opens upward if a is positive, downward if a is negative. So these are parabolas that we've seen last semester when we graphed quadratic equations. Has the focus at h, comma, k plus c. So the x-coordinate of the vertex will be the x-coordinate of the focus, but the y-coordinate will be shifted by c. And that makes sense. Let's say this parabola opens upward, and let's say here's my vertex at h, comma, k, and here's my directrix, this line here. Then the focus is going to be up here, where the x-coordinate is the same as the vertex, and the y-coordinate is whatever k is plus the distance from the vertex to the directrix, because I have to go up the same distance. So if that is c, then this is c. So it's k plus c. So this is all logical, and the directrix then would be the horizontal line at y equals k minus c. Because I know the y-coordinate of the vertex, so if I go down c, I'll have the y-coordinate of this point here, which will define that horizontal line. It has an axis of symmetry, as any parabola does, and this axis of symmetry will be the line x equals h, the line that goes through the vertex and the focus and is perpendicular to the directrix. That's my axis of symmetry. And then my parabola would look like this. Okay? The parabola whose equation is x minus h equals a times y minus k quantity squared. So now the x's and the y's have changed spots, and the h is attached to the x, the k is attached to the y. It opens to the right if a is positive, and not downward, scratch that, to the left if a is negative. It has a focus at, so let's graph this and give you a sense of how this works. So let's say that's my directrix, and let's say my vertex is over here at h, comma, k. So then my focus is going to be over here, where now the y-coordinate is the same as the vertex's y-coordinate, but the x-coordinate is shifted by h plus c, shifted by c. And the directrix then will have the same y-coordinate, k, and this point here would have the x-coordinate of h minus c. So the directrix is the vertical line, x equals h minus c. Axis of symmetry then is the horizontal line, y equals k, that goes through the vertex and the focus and is perpendicular to the directrix. And my parabola would look like this. You'll get more used to this as we practice it some more. So number 3, find the vertex, focus, directrix, and axis of symmetry of the parabola y squared minus 12x minus 2y plus 25 equals 0. Then graph it. Oh, well, this doesn't look like the equation of a parabola, so let's rearrange it so that it does. And we're going to complete the square. So I'm going to group the y terms together. I'll move that negative 2y next to the y squared. I'll then make my 12x, negative 12x over here, and I'll move the 25 to the other side as a negative 25. And in fact, let's move the 12x over there too. Why not? Okay, now let's complete the square with y. How do I know to do it with y? Because y is squared already. So I will take negative 2 divided by 2, that's negative 1, and I'll square that, and that's positive 1. So I need to add a 1 to the left-hand side. If I add a 1 to the left-hand side, that means I have to add it to the right-hand side as well. Okay? That means I can then factor the left-hand side as y minus 1 quantity squared. That's what completing the square lets me do. And that equals 12x minus 24. Now this looks more like a parabola. If I just factor out the 12 over here, get x minus 2, and I divide both sides by 12, I get 1/12 of y minus 1 squared equals x minus 2. That's my equation then. So, what's the vertex? Well, the vertex is hk, 2, 1. Okay? What is the focus? Well, how is this parabola going to open? The y term is squared, so it opens horizontally, and the a is positive, so it's going to open to the right. The vertex at 2, 1, it's got to open to the right. That means the focus is going to be to the right of the vertex. The directrix is going to be to the left of the vertex. How do I find what those are? I use my A, which is 1/12. And 1/12, A, remember, is 1 over 4C. A is 1 over 4C. C is the distance from the vertex to the focus and the distance from the vertex to the directrix. So let's solve this for C. Multiply both sides. Alright, cross multiply really. 4C equals 12, so C equals 3. That means if I go a distance of 3 to the right of the vertex, I'll get my focus. My vertex was at 2, 1. My focus then must be at 5, 1. If I go a distance of 3 to the left of the vertex, I should land on the directrix. That would be that point there, which is at negative 1, 1. So the directrix is the vertical line that goes through that. Okay? Now, how am I going to graph the rest of my parabola? Well, I should plot some points. So I know what happens when x is 2. I get 1. What happens when x is 3? I plug in 3 for x. I'll have 3 minus 2 on the right-hand side. That gives me 1. I can multiply both sides by 12. And I'll have y minus 1 quantity squared equals 12. I can then, so let me write this over here, y minus 1 squared equals 12. I can take the square root of both sides. I get y minus 1 equals plus or minus the square root of 12, which is really 2 radical 3. And then I can add 1. Well, that's not a very friendly thing to graph, but I can get a decimal approximation of it. So if I were to take 1 plus 2 radical 3, I would get 4.46 or 4.5-ish. So that will give me a good estimate of where my point should be. So right around halfway between 4 and 5. Okay. Now what if I take 1 minus 2 radical 3? 1 minus 2 radical 3 is negative 2.46, or about negative 2.4, or negative 2.5. So I will go down halfway between negative 2 and negative 3. So these are not exact points, so I'm not going to label them because I don't want my graph reader to misinterpret it. But that just gives me a sense of how wide to make my parabola. Okay? So that is my graph. Notice there's still symmetry, and the axis of symmetry is this horizontal line that goes through everything in the middle there. It goes through the vertex and the focus and is perpendicular to the directrix. There's still symmetry. Find an equation of the parabola that has vertex 4, 2 and directrix y equals 5. Okay? So I'll just make a quick sketch to get a sense of where this is and what direction it's opening and all of that. So vertex of 4, 2 would be there. Directrix y equals 5 is this horizontal line. So if the directrix is above the vertex, then the focus must be below the vertex. What's that distance from the directrix to the vertex? Well, that's at 5, and this is at 2, then that's a distance of 3. So if I go down 3, I'll be down here. So my focus must be at 4, negative 1. The vertex at 4, 2. The directrix is the line y equals 5. So C, which is the distance from the vertex to the directrix, or the distance from the vertex to the focus, has an absolute value of 3. But since the focus is below the vertex, C is really negative 3. So this opens vertically, so that means the x term is squared, the y term is on the left side, so I must have y minus k equals a times x minus h quantity squared. Alright? A, remember, is 1 over 4c, so let's find a. A is 1 over 4 times negative 3. A is negative 1/12. Now if I forgot to make c negative, all I have to do is think about the graph, know that this is going to open down, so a must be negative. Okay, so I need to make sure my a has the correct sign. So if I forgot to make c negative, I should notice here that a needs to be negative, and I would make a negative. Alright, my vertex is 4, 2, so that means k is 2. So y minus 2 equals negative 1/12, that's my a, to x minus 4 squared. And that's my equation. I used a sketch of the graph to get a sense of which equation to use. Is it going to open horizontally or vertically? Opens vertically, then I use the one that I use where the x term is squared and the y is on the left. If it opens horizontally, I use the other one where the x is on the left and the y term is squared. You'll have plenty of practice with this in class, and here's 2 more practice problems. Number 1, if a parabola is focused 4, -3 in a directrix y equals 1, find its vertex. That one shouldn't be too difficult. You're just finding the coordinates of the vertex, knowing that it's halfway between the focus and the directrix. Number 2, find an equation of the parabola that has vertex -1, 1 and directrix y equals -5. That one is just like the last example I did. And that is the end of section 9.3.